In today's session, I'm going to discuss the hydrometer. Now, a hydrometer is a floating instrument that is used to measure relative density of liquids. In other words, it can be used to test the purity of a liquid. Now, before I dive deeper into this hydrometer thing, let's first use an illustration to illustrate what we call a simple hydrometer. So before our screen, we are having two conical flasks. This conical flask contains a thick liquid we are calling porridge. It is maize porridge. We get maize flour and we mix it with water and we make what we call maize porridge. We mix it with hot water. It's maize flour with hot water and it's porridge that is taken in as breakfast in most Ugandan schools. Then in this conical flask right here, we are having water. So take note that the levels are the same. The levels are the same. So what I'm going to do, I'm going to get a test tube and drop it right here, and also get the same test tube and drop it right here. What I'm trying to investigate in doing so is to what depth or where is the test tube going to sink deeper? Is the test tube going to sink deeper in this liquid or in this liquid? Remember, this one is of a lower density than this one. This one is thick, so its density is higher. This is water, it's light, so its density is lower. So when I get my test tube and I drop it first in water, you realize that this test tube, when it drops inside water, it's going to go really inside. Like, no portion of that test tube is going to remain up here. It's inside. So now let's compare this and let's drop it in here. We get the same test tube and drop it in here. When I drop the same test tube in this porridge that is quite thick, you realize that not the entire test tube does not sink. There is some portion of the test tube that remains on top. So you realize that when we put the test tube in water, it sank deeper than when we dipped it in porridge, which was thicker. How do you know that this is sunk deeper? When you put the test tube here, realize that there was no portion of the test tube that remained up lingering. So a bigger portion of the test tube sank into this water. But when we got that same test tube and we put it in this thick porridge, you realize that it didn't sink that deep. Part of the test tube remained, a certain portion of the test tube remained up, exposed above the conical flask. So in other words, you realize that in the water, the test tube sinks deeper than in the porridge. This means that the higher the rod floats, the higher the density of that liquid. This porridge being thick means that the density of this porridge is higher than the density of this water. Now, since when we put the test tube in this porridge, the test tubes floated higher, or it didn't sink as deep as when we put the test tube in liquid, it simply brings us to this conclusion that the higher the rod floats, the higher is the density of the liquid. And so just by using that test tube, we're able to tell that this porridge is of a higher density than that. Because why? Because when we put that test tube in this thick porridge, it floated higher than when we put it in this water. So I'm going to go ahead and use diagrams to illustrate this further. So here is a diagrammatic representation of what we've been illustrating earlier. Let's take these to be our beakers, and these were test tubes that were floating in these beakers or in the conical flask like you had seen earlier. Now this, when this test tube was floating in the water, there is a certain length that was floating in water which we are calling LW, and when it was in porridge, there is a certain length of the test tube that was floating, and that is what we are calling length P, LP, the length of the test tube that was immersed in the porridge. Now from the illustration or from our earlier experiment, we were able to see that when we put this test tube in water, it sank deeper than when we put that test tube in porridge. In other words, the length of the test tube that is submerged in the water is smaller than the length that the length of the test tube that was submerged in the water was bigger than the length that was submerged in the porridge. Meaning that when we put the thing in porridge, it floated higher than when we put it in water. The test tube floated higher in porridge because the porridge has a higher density than water, and that was how we were able to determine that this porridge is of a higher density than water. Now let's get into the mathematics behind this. Of course, this is a test tube that is floating in a liquid, and because it is floating, this means that we are going to use the law of flotation. The law of flotation says that a test tube or any floating body, whether it is wholly or partially immersed in a fluid, it will displace its own weight of fluid. Meaning that when we are looking at this test tube, when it was floating in water, it displaced its own, the weight of water that was displaced is equivalent to the weight of the test tube that was floating. Likewise, when the test tube was immersed in porridge, the amount of porridge that was displaced by this test tube, the weight of that porridge is equivalent to the weight of the test tube. And so we are going to use that principle to derive the expression that the length of the test tube that is immersed is inversely proportional to the density of the liquid. In other words, the length of the hydrometer immersed is inversely proportional to the density of the liquid. So now, weight of the liquid displaced, in this case, the liquid we are talking about is water. So the weight of the water displaced, we are looking at this test tube immersed in water. The weight of the water that is displaced, we said, is equivalent to the weight of the test tube, and this expression, this statement is derived from the law of flotation. Definitely, weight of the water that has been displaced is given by the mass of the water, multiply that by gravity is given that by the weight of the test tube. So from this step we go there, the mass of the water that is displaced, mass is given by density times volume. So mass is going to be the density of the water, multiply that by the volume of the water that has been displaced, multiplied by gravity is still given by the weight of the test tube. And definitely this will end up being the density of the water times, now the volume of the water here, this volume is given by the cross-sectional area of the tube, multiply that by the length of the tube that was submerged in water. This is what we mean, that this is the cross-sectional area of the tube times the length of the tube that was submerged. It gives us the volume, the volume of the water that was displaced. And so this expression is giving us the weight of the tube. So this is like our first expression of the weight of the tube. So we go ahead and do the same for the law of flotation is applied when we had immersed the tube in porridge. So again, when it comes to porridge, the weight of the porridge displaced is equivalent to the weight of the tube. Now we are looking at this. Of course, this is given by mass times gravity. The mass of the porridge, multiply that by gravity, is given by the weight of the tube. So the mass of the porridge is given by the density of the porridge, multiply that by the volume of that porridge that was displaced times gravity is equal to the weight of the tube. So this gives us the density of the porridge, which is right there, multiply that by the volume of the porridge. Now the volume of the porridge that was displaced is given by the cross-sectional area of cross-sectional area times the length of the tube that was submerged. This gives us the volume of the porridge that was displaced, and this is exactly what we did here, that it's going to give us the cross-sectional area of the tube, multiply that by the length of the tube that was submerged, which we are calling LP, to give us the volume of the porridge that was displaced, multiply that by gravity, and this is the expression for the weight of the tube. Since we use the same tube, we're using the same tube, it means that the test tube we used here is the same test tube we used here. It means that the weight of the tube in both cases is going to be the same. So what does that mean? It means that we are going to equate both expressions. So this is our expression number 2. We use the same test tube, it means that this expression is equal to that expression. The weight of the tube when it was immersed in water is the same as the weight of the tube when it was immersed in porridge. So doing that, this gravity and that gravity cancel out. Of course, the cross-section area of the tube is the same, so they cancel out as well. So you remain with the density of water times the length of that was immersed in water is going to be giving us the density of the porridge. Multiply that by the length of the tube when it was immersed in porridge right there. So we end up with the length that was immersed in water, divided that by the length immersed in porridge, is given by the density of the porridge, divided that by the density in water. Now you realize that the density that was immersed in density of porridge, divide that by density of water. You realize that this expression could as well be referred to as the relative density of porridge. Remember, by definition, we say in our previous sessions that relative density is the ratio of density of a substance to density of water. So this is relative density. So meaning that relative density in this case is given by the length, can be given by the length of the tube that was submerged in water, divide that by the length of the tube that was submerged in the porridge. So this is one way of finding relative density when you're dealing with hydrometer. So by just this expression, we have been able to see that the length of the tube that was immersed in water is inversely proportional to the density of water. It's the same, that the length that was immersed in porridge is inversely proportional to the density of the porridge. And we can also find relative density by looking at the length that was immersed, the length of the test tube or the length of the hydrometer that was immersed in water. Divide that by the length of the hydrometer or the length of the test tube. In this case, that was immersed in porridge. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.